Good afternoon, everybody. Today I will discuss about what is the theoretical impact of instrumentation system in our practical work in industry. What we have taught in our diploma or in degree college by our eminent professors, that is totally somehow related to our practical uses in industry. For an example, today I am going to describe you the basic flow measurement. What are the basic flow measurement in process industry? There are many things to measure the flow, either volumetric or mass flow. Depend upon that what theory we have been taught in our college by our professors, that is 100% applicable to our industrial work. And there is some little bit difference which I will make clear in my slides, so that engineer, when he passed out from industrial instrumentation and control engineering, the core value or the core system or the core process which he or she is going to face in industry is somehow a corollary between the theory and the practical. Let's see the demonstration which I am going. Let's see flow measurement, a corollary, theory and practical. Here we will see the basics of flow measurement which we have been taught in our college, and its practical implication in process industry after you pass out from your college, and what you will do, what theory you have been taught in your college and its practical usefulness. In session 1 I will show you the basics of flow measurement theory part. Okay, let's proceed. What you were taught by your respected professors in diploma or degree level, these are the things you have been taught. Basic measurements are of 4 types: flow, level, pressure and temperature. And other measurements are speed, force, acceleration, load, vibration, analytical type, pH and conductivity, torque, dew point, moisture, humidity, specific gravity and many more, etc. In this discussion we learn only one type of flow measurement. As name says, flow measurement is an essential part of process system to maintain the quality and quantity of end product. The flow of gas, steam or water are widely classified by means of volume or mass. So density and flow profile plays a vital role in this system. As we know, density and flow profile are 2 vital things which can change the flow measurement system if it is not handled accurately. Okay. Back to basic. We know we have been taught in our 10th or 12th standard, density equal to mass by volume, mass flow rate equal to mass by time, and volume flow rate equal to volume by time. Mass flow is independent of pressure and temperature factor, whereas volume flow rate needs pressure and temperature correction, and it's easy to use in process industry. The corrected volume V2 is V2 equal to V1 inside bracket 1 plus xi plus into delta T, where xi is the thermal volume expansion coefficient and T in Kelvin is specific fluid property temperature. At the normal volume, Vn is Vn equal to V into 237 divided by 237 plus T into 1.013 plus P divided by 1.013 is the atmospheric pressure, where V equal to operating volume in meter cube, T is the operating temperature in degree centigrade, and P is the operating pressure in bar. This is the correction factor in case we are considering a volume flow rate. Okay. Now we'll discuss some fluid mechanics properties also before we proceed. These are the viscosity profile. It is characterized by the ability to shape, change, and resistance to shear force is the viscosity profile. The kinematic viscosity nu is the density related viscosity and has a unit of meter square per second. You see the formula is written there, nu equal to N by rho. And the most important by which a flow is decided whether it is laminar or laminar or turbulent is defined by its Reynolds number. If a flow is less than 2000, then flow is turbulent, else laminar. The formula for Reynolds number is Re equal to diameter of pipe multiplied by average flow velocity divided by kinematic viscosity. Here we are interested to discuss about turbulent flow as per industrial closed pipe consideration, because we need turbulent flow in pipelines where flow is considered. There is some turbulence, we will not get 100% laminar flow inside process pipelines. So our basic consideration here is turbulent flow. So you see, in case of laminar flow, the velocity profile is straight. Here the velocity is straight lines, whereas in case of turbulent flow, the velocity profile is some type of converging or diverging type. Okay, it is not constant, it is not linear. Okay. The energy equation. The main three type of energies are countable in case of liquid, gas, and steam flow measurement. Potential energy, mass, gravity, height, pressure energy, mass multiplied by static pressure by density, and kinetic energy, mass multiplied by square of flow velocity divided by 2. Integrate these energies, we will get energy equal to mgh plus mass multiplied by pressure by density plus mass multiplied by square of velocity by 2. Now you see the flow rate derivation. This is the main things from where we will get our flow rate, and after getting flow rate we can put any type of your flow meter. The Bernoulli law of conservation of energy states that the sum of energy at every location in the flow passage must remain constant. Expansion must be considered for compressible gases when energy is neither externally added nor removed. Now let us consider the situation of a varied cross section of a closed pipe or channel. The incompressible fluid flow for both the channel will be P1, A1, B1 and Z1, and for channel 2 P2, A2, V2 and Z2 above reference or datum level. You see the figure? These are the two different cross section area. These are the two different cross section area. This is P1 and Z1, and that is P2, V2 and Z2. These are the two different cross-section area of our shown diagram. So we will get different flow here and different flow here, because the cross-section area here is smaller than that of cross-section area of this portion A and B. Now from Bernoulli's equation, you have been taught all these things. If you put the formula, keeping the datum label Z1 equal to Z2 and applying the equation of continuity V1A1 equal to V2A2 for incompressible liquid, and putting the different diameter of different cross section area, finally we'll get the flow rate. Finally we'll get the flow rate, where Q equal to V2A2 or Q equal to A2 by square root 1 minus beta to the power 4 multiplied square root of 2z by xi in bracket P1 minus P2. The above equation gives the flow rate by mean of differential pressure against restriction, which vary the static pressure against and after the restriction, variation in cross-section area of restriction. So the restriction I am talking about here is the basic restriction, or the first restriction, or the first obstruction is orifice plate. I am considering the case of orifice plate. The types of orifice plates are eccentric, concentric, segmental and quadrant edge. Here we will discuss about concentric type, as they are widely used in industry. So this is the discussion which you have already learned, or which you were already taught by your professor in your theory classes. Now it's time to have some practical implication of this theory. What we have learned, what we have discussed in this session, in these slides, we will see what are its practical implication. Suppose you are a instrumentation engineer and you joined industry, process industry, and your boss gave you a task that you have to install one differential pressure measurement system in a process flow line. So what you have to do, what you will do first? You have been taught everything in your college. Now what you will do? You got puzzled what to do. This is a new thing for me. How I can start? How I will get the data? So not to confused, I will give you the basic concept from where you should start. So in this section we will see basic of flow measurement, practical impact. What instrumentation and control engineer do in core industry after their degree or diploma? Let's proceed. Task: installation of a differential flow meter in a vertical or horizontal pipeline with water is the flow medium. This is the task. Okay, here vertical is written. You can consider vertical or horizontal both. Okay, here I have considered the example of horizontal pipeline. So your task is first visit the place of installation. Have a look on the site. First you visit the site and see the position. Next, start collecting process data from hookup drawings provided by vendor or operation persons. You will get various manuals regarding that work. You will get the hookup drawings also, PID PID drawings also. Go refer, look for manuals, handbooks, search net, and you will get some data. You ask your operation person what is your requirement, what is the pipe size, what is the discharge capacity of that line, A to Z. What query come to your mind, you just note it down in your notebook, and after that provide process parameter data to vendor and ask for suitable quotation. Next, you what data you have collected, just you give it to your vendor. Okay, you give it to your vendor and they will accordingly give you the drawing of that on based of that required data. Next, after providing data to vendor, they will give you a drawing. You have to just confirm that drawing whether it is right or wrong. If any changes is there, you make the change and again give it to the vendor. And finally, when they will say that, sir, just you will go to indent. Indent means you have to give this document. You have to need some documentation that you are procuring these things. And after that, all official work, when you will receive the material from store, go erect it and configure it to your logic controller. Before start, have some basic concept. You see, for gases, this is the orifice plate. For gases, these are the isolation valve. The transmitter should be always installed above the orifice plate. For steam, here is 5-way manifold. This is your equalization and these two are isolation for these two tappings. Here in case of steam line, this is the orifice and this is the position of your transmitter. In case of liquid, this is the orifice, this is the two isolation valve, and this is again a 3-way manifold, isolation, equalization. This equalization is provided to equalize the pressure of these two pipelines, and this is again your transmitter. This is the basic diagram. Before installation, you have to keep in your mind. So what is the process, either it is for liquid or steam or for gases, and accordingly you have to procure your material. Keep in mind that not only you have to procure the orifice, you have to procure the related transmitter also, and you have to give the size, tubing size, pipeline size. You have to procure the isolation valve accordingly, and also manifold, which type of manifold you require and what is the withstand pressure of the manifold. Keep it in mind. Next, process parameter data. This is the process parameter data. I have done a practical in my industry. This is the orifice plate assembly. This is the line size, fluid water, orifice plate material, SS316 is a SS grade, stainless steel grade material, orifice plate thickness 4 mm, piping material MS, mild steel, temperature ambient, absolute pressure 6 kg per centimeter square, fluid velocity 1.5, standard of flange, NC 150 class, flange material carbon steel with nut bolt washer and gasket, types of tapping, flange tap, half inch, BSP British or NPT, manufacturing standard ISO 5167.2003, TP transmitter type Honeywell map with local display with dimension 184, 92, 150, power supply 230 volt and quantity 1 set. This is the indent I have done. This is the format of indent. This is the description of material, orifice plate with transmitter, 150 NV line. Unit of measure number 1 required by that, process water for flow measurement. You have to give this to your higher authority so that they can procure the material according to your information given. And this is the erection part. I have erected the thing in horizontal pipeline. You see, this is the orifice plate. These are the two tappings. Remember, this should be this is the upstream and that side is the downstream. This is the 5D. Upstream should be 5 diameter of this orifice and downstream should be 2 diameter, 2D. This is the radius tap, these two isolation valve, and this is the 3-way manifold, and this is our differential pressure transmitter. Keep in mind what I have told you initially, that in case of water, the transmitter should be installed below this orifice plate. Let's move to our next slide. This is the reading of the transmitter. Actually, what is the flow? This is the showing the flow value, and this is our IO assignment in our logic controller. The process is cooling water return flow. This is the tag number. You can do it by art calibrator by configuring with it transmitter, and this is your tag. This is your channel number, controller channel number, and this is the rear side or the back side of the controller. This is where you have to put this AI of the analog signal which is coming out from your transmitter. You have to connect in this location. This is the TV detail. This is your IO assignment table. You will know gradually when you do this thing by your own. And finally, loop test, logic controller connection, FBT and display. And this is the logic. This is the block. And this is the controller number. This is the EI input is coming. You see what raw value it is sensing from field, and after processing in this block, this is providing the process value that 75.66. If you see my slide, this is 74.1, and the process value what I am getting is near about 75.6. This is the process value, and this is the inbuilt logic data acquisition and control, where you have to give the auto make a flow their name unit, and this is the linear flow PV characteristics. This is a type of your control, PID control, where you have to give your characteristics and source. All these things you have to make in this logic, and these are the two interlocks which is coming. In case of this flow meter is off, this should be, or from these two links we will get the value, so that this is the type of interlocks. So after getting 1 and 1 here, it will give an output logic OR, and after getting this green signal means this is high, and from these 3 values, when all 3 values are true, some output is coming out. You see 75, the process value is coming out. That means some interlocks is also there, pumps interlocks or other motors interlocks. Here it is the tag number, and this output is going to our main data acquisition controller, and from there we will see in our graphics that our flow is this much in meter cube per hour. This is the alarm, this is the main section, and this is the chart part. In my next session, we will discuss about magnetic flow meter, which works on Faraday's principle. So stay tuned and keep watching my instrumentation site. I will come up with many different types of instrumentation systems, process systems. So thank you for now. I hope all of you enjoyed, all of you understand what is the difference or what is the theoretical implication in industry practically, and I hope you also try to do all these things by your own. In case of any query, you reach me the email address which I have provided in this link. Thank you.